Measures of average. By the time we finish this section, hopefully we'll be able to do these things. Compute the mean of a data set, the median of a data set, the mid-range of a data set, the mode of a data set, and also the mean for grouped data. Data that is presented in the form of a frequency distribution table. Compare the four measures of average. Okay. The pros and cons of the measures of center of a data set. We'll look at that to summarize this section at the end here. All right. Now, the word average usually means the center of a data set or a distribution. Measures of average are also referred to oftentimes as measures of central tendency, and they include the mean, the median, mode, and the mid-range. Usually the mid-range value is not used very often. This one you don't see even reported by most statistical software packages. The mean, median, and mode are the ones that are usually referred to most as the measure of the middle of a data set. Okay. All right, now symbolism in statistics. One intimidating aspect of a course in statistics is its symbolism, mathematical symbolism. And statistics likes to draw a lot of its symbols from the Greek alphabet. This sideways looking M symbol is called uppercase sigma. It comes from the Greek alphabet. And whenever you see that symbol, that indicates that you're going to be adding things together or summing things up. Okay. So for that reason, we call this sideways looking M here, we call it oftentimes summation notation, because it means you're going to be adding things up. Now, when you add the summation notation, uppercase sigma figure, and to the right of it, you have a variable. That means you are going to sum up all the observations in a data set. All right. And so let's apply it to finding our first statistic from a sample called the mean of a data set. And to do that, we're going to add up. Suppose we have n observations in our sample. X sub 1, X sub 2, X sub 3, X sub 4, X sub 5, X sub 6, X sub n minus 1, all the way up to X sub n. We have n observations in our sample or data set. How would we find the average or the mean of this data set? Well, we would add all these observations up and then divide the sum by n, the total number of observations we added up. That's how we find the unweighted average of a data set. Or sometimes we call it an equally weighted data average. Notice the symbolism that's used to represent the mean of a sample is always X bar, X with a little bar over it. Again, that symbol is universally used in all statistics books to represent the mean of a sample. So let me make note of that. This is the symbol that is used to represent the mean of a sample. All right. On the other hand, if you want to find the mean of a population, you would use this symbol here. This looks like a U. It comes from the Greek alphabet. It is called mu. That's its name, mu. And mu is the symbol that represents the mean of a population. That's the symbol that's used universally in stats books to represent the mean of a population. Now, what's the difference between a sample and a population? Did I indicate that to you? The difference between a mean and a population and a sample? Does anybody recall me having indicated that to this class or not? Does anybody want to take a guess as to the difference between a population versus sample?
Sample is supposed to be representative of the population.
Yeah, so usually which one has more observations, population or sample?
Population.
The population, yeah, the population consists of all entities or subjects that pertain to a particular study. A sample is always a smaller subset of a population. And so the size of a sample is always smaller than the size of a population. Okay. All right. Any result, ladies and gentlemen, that is computed from a sample is called a statistic. So, by definition, X bar is a statistic by definition because it is a value computed from a sample. So again, the definition of a statistic is any quantity that is computed from a sample. Contrary to that, any quantity computed from a population is called a parameter. So mu, the mean of a population, is called a parameter. All right. And notice the difference in symbolism. Although they do indicate we do the same thing, we add all the observations up and divide by the number we added up. The symbolism is different for the mean of a sample versus for the mean of a population. Notice the difference in symbolism here. All right, so let's get back to the mean of a sample. We would add up all n observations of our sample and then divide that sum by n. That's how we find the average or the mean of a sample. To write this more compactly, instead of writing it out in long form like this, we could use compact summation notation. That would be indicating that the numerator of this fraction is nothing more than the sum of all the observations in the sample. That's what this notation is saying. You sum up or add up all the observations in your sample, then you divide that sum by the sample size n. So this is a more compact way of representing the mean of a sample. Okay. So whenever you see that sideways looking n, that uppercase sigma character, that means you're always going to be adding things together. Any questions about any of this symbolism here so far? All right, here's an example. Here's an example of finding the mean of a data set. Suppose we have a list of salaries for Vandalay Industries. I'm not sure what that company is. I've never heard of it in my life, but that's not important. What's important is that we have some salaries from various employees. Okay, so for instance, Jerry is an employee at this company, and Jerry made a salary of $58,000. I don't know. This seems like it might be dated when you look down through these salaries here. I don't know. I mean, I don't know how recent this is here, but suppose these are salaries of these employees. Suppose you want to find the mean of these salaries here. All right. So, ladies and gentlemen, how would we find the mean or the average of these salaries? We would do what?
Add them all together.
Add them all up and then divide by 1, 2, 3, 4, 5, 6, 7, 8. Now we divide by 9 because there's 9 salaries or 9 data points that we added up. All right, so let's go ahead and do that. Add all these 9 observations up. Then we divide by 9. Let me see what they did here. Oh, you know what they did? They chopped off the last 3 zeros of every observation. So it's understood if we say you see the number 58, it's not just $58 for a salary. It's 58 what? Thousand. Understood. These are in thousands of dollars. Okay. So therefore, the average salary is $149,800, or you could say $149,800 would be the average salary. All right. So the mean salary again is $149,800. I have a question for you. If you look at that average, which is pretty close to $150,000, is that mean salary, $150,000, indicative of all the salaries in general of our employees? Yes or no? Do you think that $150,000 mean salary is a good representation of the salaries in general here?
No,
Not at all. Doesn't look like it at all. In fact, most of the employees, the majority of the employees make well under $150,000. So what the heck's going on here? I thought the mean or the average was supposed to be the measure of the middle of a data set. Well, ladies and gentlemen, it's not doing a very good job in measuring the middle of this data set, because the middle, just by scanning over these salaries, I can tell you that the middle is not 150,000. What salary is greatly affecting the mean of this data set and giving us a deceptive image as to what the salaries really are?
Newman.
Yeah, Newman. What's up with the $944,000 compared to these other salaries? Okay. In fact, ladies and gentlemen, we would probably classify this observation in our data set as being what is called an outlier. It's an outlier, meaning it's an observation that doesn't seem to fit the other data points. It's much larger than all the other data points in the data set. We would classify this as being an outlier. So we're finding out very rapidly that the mean of a data set is highly susceptible to outliers in a data set. If a data set is plagued with outliers, that's greatly going to and adversely going to affect your mean's ability to accurately represent the center of the data. All right, that's a bad thing about the mean. It is too sensitive to all your data points, and it really is sensitive to this outlier $944,000. And that basically corrupts the mean from being, like I said, a good representation of the middle of this data set here. It's a very poor measure of the middle of this data set, okay, because of the outlier. Now, if we threw this outlier out of here, if we got rid of that outlier and then found the mean of the remaining 8 salaries, you can bet that the mean would be a much better representation of the true middle of the data set here, okay? But that outlier is an issue here, all right? And because of that, we're going to discover in the near future here that if your data set is plagued with outliers, we should not be using the mean as a measure of central tendency. We really should be using maybe like the median, because the median is immune to outliers. The median is not affected by outliers like the mean is, okay? All right, so that outlier is throwing things off big time here for the mean's ability to determine the middle of this data set. But nonetheless, I mean, it is a salary in amidst all the other salaries of our employees. Yeah, it really just doesn't look like it fits here at all. Okay. And this is just basically re-emphasizing the fact of what I just explained, ladies and gentlemen, that the mean, although is about $150,000, is a very poor representation of what, in general, the majority of the salaries are. And that's thanks to this outlier value of $944,000. Okay. All right. So is there another statistic we could have computed from this data set that would be a better measure or a more accurate measure of the center of the data set? The answer is yes. It's called the median value of a data set. The median value of a data set literally is the middle value of a data set. But the thing is when you find the median value, it's critical that you must always arrange your data in order. You must always order your data first. If you don't order your data, you're not going to be able to find the median of the data set. So number one requirement, you must first order your data set. All right. So how then, after we order our data set, would we compute the median? Well, step number one, again, make sure your data is ordered from smallest to largest. Actually, largest to smallest would also work in your ability to determine accurately the median, but normally it's smallest to largest. Step two, the number of data values, if the number of data values is odd, okay, if it's odd, then, ladies and gentlemen, the median is going to be the value in the exact middle of the data set. It literally will be the middle value of your data set. If, on the other hand, your data set consists of an even number of observations, then the median is going to be the average or the mean of the middle two data values in your data set, and may or may not actually therefore be a data point in your data set. Okay. All right, well, that's great, but this, probably, is a lot very theoretical, and it would be great to have a good example to breathe life into these steps here so we can more easily understand what they're trying to say. So why don't we try to, find the median of an actual data set? That'll bring this stuff to bring it into focus here. So here we go. So, ladies and gentlemen, why don't we find the median salary for the Vandelay Industries? And then we'll compare it to the mean, which we already found to be $149.7 thousand, I believe. Okay, so how would we do that? First, we need to order those salaries from smallest to largest. And notice these have been ordered now from smallest to largest, left to right. And now that our data is ordered, we can begin to accurately determine the median value of this data set. Notice there were 9 observations in this data set, and 9 is an odd number of observations. And because of that, the median literally will be the middle value of the data set, which is to say there will be 4 observations to the left of that value and 4 observations above the median. So 1, 2, 3, 4. So it looks like 53,000 would be literally would be the median of this data set. That is the median value of the data set, because you have 4 observations to the left of that value and 4 observations to the right of 53,000. So that's literally the middle of the data set. So you can see that the median, is totally unaffected by this outlier here. It still accurately measures the middle value of your data set, the middle of your data. Whereas the mean, ladies and gentlemen, was about 147,000. Do you agree? The mean would be way up here, correct? Somewhere in here. Look at how lousy of a job the mean does in locating the center of this data. Terrible job. That's because it's affected by this 944,000. Whereas the median is totally immune from this outlier. Regardless of the outlier in the data set, it still determines accurately the middle of the data set. Okay. So why use the mean? Why not just, compute the median all the time? Well, of the two statistics, the median and the mean is more sensitive to all of your data values in its computation as opposed to the median. The median basically just takes into account the ranks of the data points and not so much the values of the data points. There is the difference. So the median, although a good measure of the middle of the data set, is really does not take into account the actual values of your data points, your data set, whereas the mean does. So because of that, because the mean is more sensitive to the actual values of your data in your data set, the mean does have some value. And it does have a lot of value, especially if you don't have any outliers. And most data sets don't have outliers, in all honesty. It's kind of rare to have outliers, but this one obviously does here. Okay. All right. Now, here's something interesting, ladies. What if we tossed out that outlier value? What if we tossed out the $944,000? And let's find the average now of this remaining data set that now has 8 observations in it. Well, to do that, we would add up all these 8 observations and divide by what? Divide by 8, correct? To find the median of this data set, it would be the average of the middle 2 data values in your data set. That is to say, it would be the average of these 2 middle values right here. Because notice you have 3 observations to the left, and you have 3 observations to the right. So the median is going to be dead center between 52,000 and 53,000. And to find the median value, you would literally find the mean of these 2 middle values. Add them together, divide by 2, and this would be your median value here. That's your median. Notice in this case, the median is not actually a data point in our data set. Although it lies between 2 data points in our data set, it itself is not a data point in the data set itself. Okay. All right. By the way, what would be the mean of this data set? Get on your calculator and add those 8 observations together and divide by 8. Tell me what the mean would be. So go ahead and do that. Just add all those up, divide by 8. Let me know what the mean would be. All right, everybody get the average, the mean? Well, I think they
Who
figured
did
out.
you want us to divide by again?
Now you gotta divide by 8. You're gonna add all the observations up and divide by 8. So it looks like the mean would be 50,500, correct? All right. So notice both the median, 52,500, and the mean do a pretty good job now in locating the middle of this data set here when the outlier has been discarded or thrown out. Okay. So again, outliers greatly affect the mean, but do not affect the median. So if your data set does have outliers, you probably would want to use the median as the measure of the middle as opposed to the mean. Okay. All right, the mid-range value, like I said, is not really used too often. It is nothing more than the average of the minimum value in your data set and the maximum value. So if you take the minimum value in your data set and add it to the maximum value and divide by 2, you get what's called a mid-range value of a data set. Okay, but in all honesty, I worked with stats quite a bit through the years, and I've worked with several software packages, and they don't really, they don't really report the mid-range value. It's not a typical value of a central tendency that's reported. Usually it's the mean or the median or the mode. But if you wanted to find the mid-range value of the Vandelay industry salaries, you would take the minimum plus the maximum observation and divide by 2, and you get 482,000. And you can see that it does a very lousy job in representing the middle of your data set. When, of course, we leave the outlier in our data set. So the mid-range is like 480,000, which is way up here. So it's also, like the mean, highly biased to outliers in your data set. And notice in its computation, the mid-range value only takes into account two data values in your data set, the minimum and the maximum value. It is totally oblivious or could care less as to what's going on in between the max and the min. For that reason, the mid-range value is extremely insensitive to your data values in general. And usually for that reason, we exclude it as a measure of the middle of a data set. All right, now what's the mode of a data set? The mode is the most frequently occurring data point in a data set. Now, it is possible for a data set to have more than one modes. If a data set has one mode, we call it unimodal. Here, I'll write all this down here. This is important to see at least once. Okay. If a data set has one mode, we call it unimodal. If it has two modes, it is bimodal. If it has three modes, what do you think it's called? Anybody? Three modes.
Trimodal.
Trimodal. If it has four, or more modes, it is buku modal. Just kidding, ladies and gentlemen, that's a joke. To borrow a word from my late father-in-law, when there's a large amount of anything, he always said buku. Buku, I guess, is Polish for meaning a lot. Now, if it has four or more modes, then we just call it, in general, we just call it multimodal. Okay. So it is possible for a data set to have more than one mode. All right, let's go down and see if we can actually find the mode of a data set. Here's a small data set, represents the duration in days of the final 20 US space shuttle voyages. Find the mode. Does anybody remember the space shuttle? Anybody remember the space shuttle? United States used to own several space shuttles. They would go up regularly into space or orbit, and then they would come back into the atmosphere and just land like an airplane on a runway. Anybody remember the space shuttle? That shows I'm starting to show my age here, correct? Well, space shuttle program ran through the late 1970s through, let's see. I think it ran all the way through the late 1990s, I want to say. Late 1990s. But there were several tragedies, namely the Challenger space shuttle blew up after liftoff, killed everybody on board. And there was another one. Another space shuttle lost some heat shields when it took off from Florida. And then on re-entry, coming back into the atmosphere, those missing heat shields caused the wing of the space shuttle to heat up. And it basically blew up on reentry and broke apart, killing everybody on board. I forget what the name of that space shuttle was. It was Columbia, I think Columbia. Yeah, so space shuttle Challenger blew up, and space shuttle Columbia disintegrated on reentry because it lost some heat shields. But anyways, the space shuttle program has been discontinued. We no longer use that in this country. I think we contract out a lot of our satellite deployments into orbit to private companies, private industries, or even foreign countries to lift our payloads into space. But yeah, we don't have a space shuttle thing anymore. Anyways, ladies and gentlemen, these were the duration and days of the final 20 U.S. space shuttle voyages. And they want us to find the mode of this data set. Now, your data does not have to be ordered in order to find the mode. The only time you have to order your data is if you're trying to find the median of your data set. So what would be the most frequently occurring data point in this data set? Anybody? Most frequently occurring.
15.
15 occurs how many times?
5, 1,
2, 3, 4,
6.
5, 6 times. 12 occurs with what frequency?
8 times.
Oh,
4, 5, 6, 7,
1, 2, 3, 4, 5, 6.
3,
6 look like
4, 5, 6, 7.
6.
12 occurs, I think, 7 times. Is that correct? 15 occurs, what, 6 times? 2, 3, 4, 5, 6. Yeah, so what data point is the most frequently occurring data point? It appears to be oh, here you go. 12 is the winner, ladies and gentlemen. So the mode of this data set is 12. It occurs the most frequently among all the other data points in the data set. 15 is a close second, though. But yeah, 12 is the only mode of this data set. There's only one mode. This would be a unimodo data set. One mode. Make sense? That's all there is to the mode. All right, let's try this one here. The number of Atlantic hurricanes for each of the years from 1999 to 2021 is shown in the list. Find the mode and describe what that tells you. This should be the year 1999 through what? The year, not 1921. That's a typo. Should be 2021. Okay. All right, ladies and gentlemen, what is the most frequently occurring data point in this data set? You know, you got to admit that if this data was ordered, that would facilitate our ability to determine the mode a little bit easier than being, having the data being all mixed up. Do you agree? Out of order. It does make it more difficult. Although you do not have to order your data to find a mode, it sure would be nice. But can anybody, let's see, 8 occurs 3 times, 4 times, right? You
Go
could
to
make a little table here if you want to. 8 occurs 4 times. 9 occurs 1, 2 times. 4 occurs 2 times. All right. 7 occurs 4 times. 9 occurs once. 15 occurs once. 5 occurs once. How about 6? 1, 3. 6 occurs 3 times. 7 occurs 1, 2, 3, 4 times. Gosh, 1, 2, 3, 4, 8 occurs 4 times 2. So what do you think the mode or modes might be here?
7 and 8.
Kind of looks like it, doesn't it? 7 and 8. Looks like there's 2 modes here, so this would be bimodal, this data set. Looks like there's 2 modes. All right. 7 and 8. So again, that would be 2 modes. Now, those numbers 7 and 8 means, how would we interpret what they're trying to tell us here? Well, over the 22-year lifespan, or 22 years, the most common number of Atlantic hurricanes was between about 7 and 8. So the modes are kind of like a measure of the middle of the data set, like the mean and the median are. All right. Okay. A survey of the junior class of Fiesta State University shows the following number of students majoring in each field. So what if we have a categorical data like this, where we have frequency counts for various categories? What would be the mode here? Well, what category occurs most frequently here? It's like the business major, correct?
Yes.
So therefore, it looks like the business major would qualify as being what, the mode. Everybody see that there? Okay. Now, how would we find the mean or the average for group data? Where our data is in the form of a frequency distribution table. Well, it can be done. And actually, it's going to be called a weighted average or a weighted mean. Whereas before, our mean of our data set, whether a sample or population, was called an equally weighted mean, in the sense that every data point had an equal weight of determining or shaping the mean, or sometimes we call it an unweighted mean. All right, but what if you have like group data in the form of like a frequency distribution table like this? How could we compute the mean of this grouped data set here? Well, we're going to show you how to do that. Okay. And here are some steps. Step number 1, we need to compute the midpoint of each class in the group data. Then we're going to multiply the frequency for each class by the midpoint of that class. Add up all the products from step 2 and divide by the sum of frequencies. Okay, so what's all that saying here? Well, for one thing, we're going to have to extend this table. We're going to need another column over here. And this is going to be called the midpoint of our frequency, of our class column, midpoint. And how do we find the midpoint of a class? Anybody got an idea how we could compute the midpoint of each of these classes here? For instance, how can we find the midpoint of 100 to 104? Anybody have an idea? How would you find the middle value between 2 values in a class? You would basically just what? Add the 2 endpoints of the class together and then divide by what?
2.
Divide by 2. So that looks like it would be what? 102 would be the midpoint of the first class. What would be the midpoint of the second class? 5 plus 9 is 14. 14 divided by 2 is 7. 107. How about 110 to 114? What's the midpoint? 0 plus 4 is 4. 4 divided by 2 would be 2. So 112. 115 plus 119 divided by 2 is the same thing as saying 9 plus 5, which is 14 divided by 2 is 7. So it'd be 117. 122 would be the midpoint of this class. What's the midpoint of 125 to 129? 9 plus 5 is 14, divided by 2 is 7, 127. Okay, 127. 130 plus 134 divided by 2 would give us 132. So now we have the midpoints. Now that we have the midpoints, ladies and gentlemen, we're going to form another column here where we're going to take the frequency. This is the frequency of each class, and we're going to multiply it by the midpoint value. I'll call the midpoints M. Okay. And it's the frequencies that provide the different weights for the different classes. That's why we're going to be calling this a weighted average. So what's 3 times 102? 3 times 102 is 306. What's that? Go ahead.
I'm just gonna say, so the F is the frequency and the M is the mode,
Midpoint.
midpoint, okay.
Midpoint of each class. Yeah. So what's 8 times 107? 856, is that correct? 856. 16 times 112 is going to be what? 1792. 13 times 117. It's going to be 1521. 7 times 122. 854. 2 times 127. 254. And 1 times 132. 132. Now what we're going to do is we're going to sum up this last column. We're going to sum up the last column. Got to add up all the values of the last column. That gives us a sum of 5,715.
So you add up both columns or just
Last column, only the
the
last.
last column? Okay.
This should be frequency times M here, M midpoint. Then what we're going to do in order to find the average of this group data set, the mean, if you will, we're going to take the sum of the last column. And we're going to divide it by the sum of the frequencies. So we're going to take this 5,715. And we're going to divide it by the sum of the frequencies. What's the sum of the frequencies here? That's the sum of this column right here. Got to add all these together. So I got 3 plus 8 plus 16 plus 13 plus 7 plus 2 plus 1 gives you 50. There we go, ladies and gentlemen. We got to take 5,715 divided by 50, and we have the average or the mean of this grouped data set. It's called a weighted average. 114.3 would be the weighted mean for this group data here. And you can see that 114.3 is kind of like in between these two classes. Do you agree? So it looks like literally the physical middle of your classes, if you will. That looks like about right. All right. All right, so that's how you find the mean or the average of a group data set, data that's in the form of a frequency distribution table. So you gotta add on a couple of columns. You gotta find the midpoint of each class. And then you multiply the midpoint by the frequency of the class. And you add the last column together and then divide that by the sum of the frequencies. So I have a question for you. Which value which midpoint value, ladies and gentlemen, has the largest contribution in forming the mean of this group data? Which one has the greatest weight? Which class has the greatest weight? Anybody? Greatest weight. All right, which class has the greatest frequency of occurrence? Because that's called the greatest weight. That
The one
would
with 16?
That's right. This is the greatest weighted class right here. So this 100, this midpoint value of 112 is has the greatest weight, if you will, in shaping the mean of this group data set, 114.3, because it has the greatest weight. Which midpoint value has the least influence on shaping our mean of this group data set?
The 130, 134 class.
Right here. This class has the least weight, the least say so, if you will, in forming the mean of this group data set. So this 132 does not have much say so or input whatsoever in shaping the 114.3. It has the least weight. Okay. Does that make any sense there? What's going on there? Okay. You know, this is also, ladies and gentlemen, how like your grade point average is computed. I don't know if you're aware of that or not. Your grade point average is a weighted average. Let me show you. Let me give you an example here. Suppose that we take a class maybe in algebra. We take a class in English. This is for one term, one semester. Maybe a course in history. I don't know. Maybe basic computers. And give me another class. Anybody?
Film,
Jim. All right.
film.
Film. Film. All right. Film. Now, these courses have what are called credit hours. Okay. Each one might have a different credit hour. And of course, we're going to have our grade that we obtained in the course. And here at Mott, we go by, you know, our grades are not like letter grades here at Mott. They are kind of like, you know, GPA grades, you know, 4.0, 3.5, things like that. All right. Suppose your algebra course is 4 credit hours. Your English course is maybe 3 credit hours. History is maybe, I don't know, 3 credit hours. Computers is maybe involved. Maybe you got a lab with computers. 5 credit hours, and maybe film is really involved. You know, maybe you got like 6 credit hours because you might have a lab, or maybe you have like on the job training or something with film, a film class or something like that. All right, give me a grade that we earn in algebra. The grades that we use here at Mott. Anybody?
4 point.
4.0. Oh, wow. Congratulations. How about an English grade? Well, if you were like me, when I started out at Mott in 1983, that's showing you how old I am. English was okay with me. I didn't fail it, but it was not my strong suit. My strong suit was computation of the sciences. But anyways, in English, I got about a 3.5. That's what I think I got way back in English 101 when I took it way back in 83, I think. History was even a weaker suit for me. I got a 2.0 in history. Yeah, that was weak. Computers, I did okay in computers. 4.0. Film. I'm a terrible actor, ladies and gentlemen. I don't know. Maybe a 2.5, maybe. All right, now how would we compute the GPA, the grade point average, here at the end of this term or semester? Well, it's going to be a weighted average, a weighted mean. What we're going to do is we're going to take the number of credit hours and multiply it by the grade obtained. So 4 times 4.0 plus 3 times 3.5. And we're going to add these products together. Plus 3 times 2.0 plus 5 times 4.0 plus 6 times 2.5. And then we're going to divide the sum of these products by the sum of our credit hours. So what would be the sum of the credit hours here? 7, 10, 15, 21. 21 credit hours. That was a busy semester. 21 credit hours. All right. Now we got to get on our calculator and dial this up, ladies and gentlemen, and you will have the GPA for that particular term, the grade point average. This is going to be 16. It's going to be 10.5 plus 6 plus 20 plus, let's see, 15, I believe. Divide that by 21. And what do we get? So what would be our grade point average for this term? This is a weighted average. 16 plus 10.5 plus 6 plus 20 plus 15. Divide that by 21. And I get a GPA of 3.2 for that semester. 3.2 grade point average. You see, the credit hours are the weights. So which class or course had the largest say-so in shaping my GPA for that term? Which class was it? Which class had the largest weight?
Film.
Film. 6 credit hours. That's a class you might want to try to get a good grade in because it's going to have the most influence in shaping your GPA for that semester or that quarter there. Which class could I maybe afford to skip on a little bit if I had to, if I had no choice?
History or English.
Maybe history or English, right? A little bit less credit hours there. So maybe, I mean, if you had to cut corners and that, that's a large load. I mean, if you work full time outside of school, can you imagine trying to tackle it? And he had a family. Can you imagine trying to deal with all that? That's a lot of responsibility. But yeah, ladies and gentlemen, this is called a weighted average. Now, it is a weighted average because in front of these grades that were obtained in the courses, you have different weights, which are the credit hours. But if I just wanted you to find the average of these grades, the unweighted average, then you know what we would do? We would just add all these grades up and divide by what? Divide by 5. This is called an unweighted average, or sometimes we could technically call it an equally weighted average because technically every one of these grades is being multiplied by the same number, namely 1. So everyone has the same weight of 1. That's why sometimes we call this an equally weighted average. Whereas this is an unweighted or unequally weighted average because the weights are different. Different weights in front. You see that? We understand the difference? So when you find the average or the mean of a data set, just by adding up the observations divided by the number you added up, you are technically computing an unweighted mean. Or technically, you could argue that it's an equally weighted mean. When you compute the mean of a group data set, or for these grades to find our GPA, this represents it represents a weighted average or a weighted mean, or unequally weighted mean. Okay. Is that making any sense, the difference between the two?
Yeah.
They're walking you through this again over here, ladies and gentlemen. Notice the bottom row has the sums here. They summed up the respective columns, they summed up the frequency column. And then they summed up this last column, which is the product of the midpoint of the class multiplied by its frequency of occurrence. All right, so I already did all the work here. They're just showing you here, and you get to 114.3. Okay. And these were temperatures. Yeah, the mean record. Find the mean record high temperature for the 50 states. And so that's why the frequency adds up to 50, because there were 50 states here. See that? So the mean record high temperature was 114.3 degrees. Wow. That's a high temperature. Okay, that's what they got. Now they're going back to that data set way back where we had those salaries. Remember from that company, the Vandelay company? And they wanted us to compare the three measures of central tendency with each other. Well, the mean was 149,800. The median was 53,000. The mid-range value was 482,000. And the mode, now, you know why they're saying this data set has no mode in it? Because there is no data point, ladies and gentlemen, that repeats more than once. There is no most frequently occurring data point in this data set. They all occur with equal frequency of one time. You know, technically, I've seen this coined two different ways in two different stats books. Most stats books would say for a data set like this that there is no mode. But I did see in one stats book where they would say, every data point's a mode in this data set. Because technically, you could argue that every data point occurs with what? Equal frequency, equal maximum frequency of one time. Do you agree? So technically, you could list every data point as being a mode. Most stats books, however, would coin a data set like this as being modal-less, no modes. All right. And I think Alex will also refer to a data set like this to have no modes. No modes. Okay. None. Okay. So now, what are the strengths and the weaknesses of these measures of central tendency here? I think I've been alluding to these strengths and weaknesses throughout the entire lecture here, so this should be kind of review. What's the strengths of the mean? Well, in its computation, the mean takes into account the values of all the data values in your data set. So it's very sensitive to all your data values. That's a good thing. You want it to be sensitive to all the data values. The mean is pretty easy to understand too. You know, you just add up all your observations, divide by the number you added up. The mean is unique. There's only exactly one mean for any data set. There's no such thing as having two means or three means or four means like the mode. There's only one mean. What are the weaknesses of the mean? I think I've indicated that over and over again so far. The mean is adversely affected by what? What are called what? Data points that are uncharacteristically higher or lower than all the other data points are called. What did I call them?
Outliers.
Outliers. If your data set is plagued with outliers, the mean is going to reflect that big time. Okay? Because the mean is most greatly affected by outliers when you compare it with your median and your mode value. The mean can be time consuming to calculate for large data sets. I mean, if you have data sets that, you know, have like hundreds of thousands or millions of data points in it, could you imagine with a calculator trying to figure out the mean of a data set that had like 10 million data points in it? It's like that old Snickers commercial, gonna be a while. Okay. Well, in that case, ladies and gentlemen, if our data set has like millions of data points in it, we normally turn it over to a computer system. that can compute, do calculations on the order of, we got computers nowadays that can do trillions and trillions of calculations per every second. Okay, for every one tick of the clock, we got some computers that can do upwards of 20 trillion calculations. All righty. So that's not really a big issue anymore. It used to be. But we have computers now that even if you have large data sets, as long as you can, scan them into your computer quickly by using some maybe handheld scan device or whatever, then the computer goes to work. And then you can sit back and relax and enjoy the speed of the computer, which is a little bit faster than the speed of a human. Okay. We can't even pick up our pencil in 1 second. Whereas in the time to just pick up our pencil in 1 second, a computer system has already done 20 trillion calculations, ladies and gentlemen. Mind-boggling, to say the least. Okay. Now, the median. What's the strengths and weaknesses of the median? The strength is that the median always is going to be physically the middle of your data set, regardless of whether you have outliers or not. It always will be the middle. It literally divides your data set into 2 groups: data values that are below the median versus data values that are above your median. And the median is not affected by outliers like the mean is. These are the strengths of using the median as a measure of central tendency. Any weaknesses with the median? Well, the median, unlike the mean, is not as sensitive to all your data values. It just basically relies on the ranks of the observations within the data set to determine its value. And because of that, it is rather insensitive to the actual data values in your data set. That is considered to be a weakness of the median, whereas the mean is sensitive to all the values of your data points in your data set. That's considered to be a strength. All right, so some strengths and weaknesses of our measures of central tendency here. What's the strengths of the mode? Well, the mode is pretty easy to find once your data, again, it depends on the size of your data set. If you got millions of data points, sifting through millions of data points that are all unordered, good luck in trying to find a mode with that. That's going to be impossible. If your data is ordered, though, ladies and gentlemen, or sorted, finding the mode is usually a lot easier. Okay. The mode, unlike the mean and the median and the mid-range value, can be used for non-numeric data or categorical data. That's the strength of the mode. For instance, if you have colors of cars, you have 10 cars that are red, you have 3 cars that are blue, you have 1 car that is green. What would be the mode color, the modal color for that data set? It would be, if you had 10 cars that are red, 5 cars that are blue, 1 car that's green. What's the modal color for that data set? It would be red, correct? That occurs most frequently. So the mean and median fall flat on their face when it comes to a non-numeric data set, but the mode is still alive. It can also be used for non-numeric data. What's the weakness of the mode? Well, some data sets may not have a mode. The mode may not be unique. There could be more than 1 mode. Then it makes it more difficult to determine what the center of the data set is if you have like 3 or 4 modes. The mode can oftentimes be different than the mean and median of a data set, which leaves you kind of like with your mouth agape wondering, what is the mode really telling me in this data set? Is it telling me where the middle of the data set is? So the mode is not without faults either. How about the mid-range value? Mid-range is pretty easy to compute as long as your data is ordered, where you know the min and the max value. It provides a first guesstimate for the average. What's the weakness of the mid-range? Well, it is highly affected by outliers. And ladies and gentlemen, it takes into account only the min and the maximum value of the data set in its computation, meaning that it totally ignores all the other data values in between the smallest and the largest data value. Because of that, it's extremely insensitive to your data. And because of that, it's not a good representation of your data set as a whole. Okay. So there's the pros and cons. Any questions about any of this here? Let's see if we can go to our textbook and do a couple problems to get paid for today. So these problems will be coming out of section 11.3. If I could ever bring it up here. . 11.3, and this is entitled Measures of Average. All right, let's go down and just do a couple problems here. All right, number 13. It says a graduate student in social work surveyed students at 10 colleges in a Midwestern state to find how many are single parents. The results of the data are below. They want us to find what for this data here? They want us to compute the mean, median, and mode, and the mid-range value. Then decide which you think is the most meaningful measure of the average for the data set. Okay, so number 13. Like I said, this data is not ordered in any way. Notice that. The data, unfortunately, is not ordered. But, ladies and gentlemen, you know, your calculator can help you, you know, find a couple of these statistics that you're interested in. But for now, I would like you to compute the mean, median, and mode and the mid-range for this data set. All right, we'll call this classwork number 1 or number 13. And when we get done with this, I'll show you on your calculator how we could have, you know, computed these maybe a little bit quicker. Go ahead and do that. Classwork 1. So there you go. I put the instructions above number 13 there. That's what they want you to do. Go ahead and do that for classwork 1. Well, then let's take a look here. To get the average of this data set, you basically just, the mean, you just add them all up and divide by 10, you get 612.6. Anybody get that? That'd be the mean.
I don't know why I didn't get that.
Hmm.
Me neither.
2, 4, 5, 6, 7, 8, 9, 10. Well, let's make sure, hold on a second. Make sure I added up all the data points correctly. Um, Hold on a second here. So, see if I got all the data correct in here. Let's see.
I got 5,613.
I got 5,503. No, 5,353.
Let's see here. Something's wrong. Okay, where's they're saying that the mean is 612.6 for number 13. 612.6. So we add all these up. Now, let's see if I got them all in a data set here. 260, 270, 280, 298, 385, 70, 638, 700, 1350, and 1380.
I got what you got now.
Got all that. I don't know, double check your work. If you did not get a mean for 612.6, I mean, just double check it. All, it never hurts to, check it out one more time. And just make sure that, we have all these data points written down correctly. There's obviously room for mistake here if we're maybe writing them down fast or very small on our paper and you can't see, or maybe we misentered them into the calculator too. That's a possibility. I mean, there's a lot of little mistakes that can occur. And it don't take much. So now I was going to show you on the TI-30 or TI-34 how you could find the mean. We might as well use it for this data set here. So now this works the same way as the TI-30, by the way. This is a TI-34. You got a button here that says data, right here, data. See that? So you hit your data button to enter data into the calculator. And when you hit data, you're presented lists, okay? And then you want to type your data into like list 1 here. So I'm going to type my data in this list here. So I'll type in like 260, enter, and then 270, enter, and I'll keep loading up this list with all my data. 380, 638, 700. Unfortunately, this calculator cannot sort your data, cannot order it, but nonetheless, you still can enter it into a list and then have your calculator crank out some statistics from this list. Now, once you got your data in your list, you're going to have to hit your your stat button. Your stat button is above your data button. To access stat, I would have to precede my data button with hitting the second key. Second key followed by the data button activates the stat feature. So second, data, stat. And then you'd want to select one variable statistics. Number one, hit enter. And you want to compute the one variable statistics for list one. Notice we have 3 lists at our disposal. So with your cursor blinking on list one, you want to hit enter to select it. Now the frequency basically indicates, ladies and gentlemen, when you say frequency of 1, that indicates that every data value you entered in has a weight of 1. And that's what you want, because this is not a weighted average or a weighted mean we're trying to compute. This data set is not group data. It doesn't have different weights per observation. So just select 1 for the frequency. And then calculate. And notice X bar is the mean of that data set, 612.6. And represents the number of observations in your data set, which is 10. This is called the standard deviation of your data set. That's a measure of variability or variation. If you scroll down, there's a standard deviation of, if you were to consider this as being a population. These are slightly different because the formulas for a standard deviation for a sample and population are a little bit different. This is the sum of all those observations in list one. If you were to add them all up, you get 6,126. So do you agree that's what we divided by 10 to get the mean? We got 612.6. This is the sum of all the squared values in the list. So every value in your list was squared first, and then they summed up those squared values. And as you can guess, it's a big number. Okay, so pretty cool. I mean, this calculator can compute some statistics from a list of data very quickly, namely the mean, right? Right there. So keep that in mind. You're doing Alex, and they want you to compute the mean of a large data set. You're welcome to put the data into a list and then select one var stats and for that list, and it'll crank out the mean of the list. Okay, so that's useful. All right, now, how would you clear a list out? Let me see something, if there's an easier way to clear this out here. No, I don't think there's an easy way. I think you'd have to just hit your delete button. Keep hitting your delete button and it will delete the data value, move the list up. Okay, until you delete it all. All right. So you do have 3 lists at your disposal here. List 1, 2, and 3. Okay. Now for the median value, your data has to be ordered, and I did sort it. Smallest to largest, left to right, there it is. And so the median can now be found, and it's literally the middle of the middle 2 values. It's the average of the middle 2 values in your data set. These are the middle 2 values, because you got 1, 2, 3, 4 observations to the left and 1, 2, 3, 4 observations to the right. These are called the middle 2 values. Finding the average of these middle 2 values gives us the median, which is 475. So 475 lays dead center in between these 2 middle values. That's your middle value of your data set, your median. There is no mode because all the data values occur with equal frequency. There is no data point that stands out occurring more than once. The mid-range is very easy to compute if your data is sorted, because we can see our minimum value is here and our maximum value is here. All you gotta do is add the minimum to the maximum, divide by 2, you have the mid-range. You can see how insensitive the mid-range is to your data set as a whole, because it does not take into account what's happening in between your minimum and maximum values. Totally oblivious to the values of these data points here. It just takes into consideration the min and the max divided by 2. So, did anybody get the median as being 475? The median. Did anybody
Yes.
the mid-range value that we got?
Yes, I got that.
60 cents. So computing some basic descriptive statistics from data sets, okay? All right, it's, okay, so I'll tell you what, like, if you got your calculator, if you want to use that, the feature I just showed you there for computing the average a little bit quicker, why don't we try that? Now, just be very careful on how you enter the data in because, you know, your statistics that you compute are at the mercy of the accuracy with which you enter the data into the calculator. So I'll tell you what, number 16, let's have you try this. I want you to enter this data into list 1 in your calculator. Whether you have an 80, a TI-30, TI-34, even a TI-84. Anybody got a TI-84? TI-84, anybody?
I do.
All right, you know, with the TI-84, it works essentially the same way. What you do with your TI-84 is you hit your stat button right here. Edit, stat, edit, hit enter to select edit, and then you can type your data in list 1. Once you get your data typed into list 1, you get out of this mode by hitting second mode to quit. Then you hit stat again, and then go over to calculate and select the one var stats function. One var stats for the list 1. Now, if you don't have L1 showing here to make it show there, you would hit your second key followed by your number 1 key, because above your number 1 key, you have what? L1, name of list 1 there. You see that? Leave the frequency list blank, go down to calculate, hit enter, and it'll crank out all the stats, okay, for that list. Does that make sense?
Yeah.
For the TI-84 user? Okay. If you want to do this problem manually, let's say you don't even have any one of those calculators can afford you any of that to enter the numbers into a list and use the one var stats function. All right, just go ahead and compute the mean of this data set. Like whether you want to use the calculator to speed things up or you want to do it manually. Let's just see if we can crank out the average of this data set, the mean, number 16. All right, so you want to enter this data either into a list, or just add all these observations up and then divide by the number of observations you added up. This is the TI-84 calculator. It is a graphing calculator. It is the calculator that is used for our statistics course here at Mott Community College, Math 150. It's wonderful in what it has available to use. It has 6 lists as opposed to just 3 lists on the TI-30. I entered my data into list 1, and I can actually sort my data very, very easily on this calculator. All I would do is after entering data into this list, I'd hit my stat button, go down to sort in ascending or sort in descending order, take your pick. You can sort in ascending order by selecting the sort A function, entering the name of the list that you put your data into. It was list 1. Second 1 brings up the name list 1. Close the parenthesis, hit enter, and the data has been sorted. Now, if I go back to stat, edit, my data has been sorted from smallest to largest, from top down in this list here. It's all been sorted now. That's an invaluable feature for helping you to find the mode of a data set. By the way, what would be the mode? 6.7 occurs 3 times. Six occurs 3 times, right? Ooh, 5.9 occurs 4 times. Looks like the mode would be 5.9. Do you agree? Yeah, 5.9 would be the mode. All right, and then if you want to find the mean, you basically get out of this list editing mode by hitting second mode to quit. You hit stat, go over to calculate, and select the 1var stats function. I want to compute the 1var variable statistics for list 1. Calculate. And ladies and gentlemen, the mean should be 5.95. That's what X bar is. Anybody get X bar? 5.95?
I did.
Okay. Notice the other statistics that are computed, the sum of all those values in that list, the sum of the squared values, the standard deviation of a sample, standard deviation of population, the number of data values, which is 20, the minimum value in the data set. U1 is called the 25th percentile, or the first quartile of the data set. There's your median, which is 6, ladies and gentlemen. Oh, wait a minute here. The median is 6. I thought it was 4.9. What the heck? Anyways, the median is sometimes referred to as the 50th percentile or the second quartile. There's the 75th percentile of your data set. 75% of your observations lie below 6.45. And there's the maximum value in your data set, 6.7. If you hit stat and go over to test, you have a wealth of statistical tests that you can use on data sets. I'm using this calculator to teach my Math 150 section, my statistics section here at Mott. We use this calculator a lot to do data analysis and inferential statistics with data sets, to do hypothesis testing and building of confidence intervals, things like that. So this is a very nice calculator. If you are going to go into stats at Mott and want Math 150 here, you might want to try to get your hands on a TI-84. Shop around. You can maybe buy a used one, save a lot of money. Students are always selling these things for reduced price around campus. Bulletin boards, oftentimes they put like, sales of these calculators on bulletin boards around campus. Just keep your eyes open. But yeah, this is the calculator you want to get if you're going to go into higher level math here at Mott. If you want to get into pre-calculus, calculus, or statistics, you want to get your hands on this machine here. Okay. All right. So today we basically have investigated how to find some measures of central tendency, the mean, median, and mode, and also the mid-range. And we talked about the pros and cons of each, the strengths and weaknesses, and how some are really susceptible to outliers, whereas others are immune to outliers. So that'll bring to a conclusion today's session here, ladies and gentlemen. If you have any questions or comments, I'll be on the line for the next couple minutes. If not, have a good day, and hopefully I'll see you in a couple days to wrap up this week.